To another lecture. Let's take a moment to zoom out now to see where we are in the big picture of data mining. So far we've walked through the first two stages of the data mining process, which is business understanding and data mining. And this week we enter a very critical phase, which is the data pre-processing or data preparation. This is where we take raw, messy, real-world data and turn it into something clean, consistent, and ready for modeling. So think of this step as the bridge between exploration and real analysis. So before we can build any useful model, we need to face a hard truth that real world data is really messy. It often comes from heterogeneous sources, meaning different databases, devices, and so on. So that means that it might have some missing values, inconsistent labels, mismatched formats. And so this is where the data pre-processing comes in. It is the process of transforming raw data into clean, usable format. So that's a very essential step because, as we say, the simple rule is garbage in, garbage out, right? So if the data going into your model is low quality, then the predictions coming out of it will be unreliable or misleading. Now, 80% of a data scientist's time is spent cleaning the data, right? So this robot right here in the machine learning class are right, so the robots here, they represent the models, and this Robbie right here is acting out, right? So the teacher threatens to send him back to data cleaning, right? So yes, data cleaning is the punishment even for AI models. So yes, data cleaning might feel tedious, but if you skip or rush this step, your models will misbehave as well, right? So it will give you noisy predictions, biased results, or just completely nonsense. So real world data is rarely neat and polished, right? In fact, most data sets you will see are full of problems, things like missing values, duplicates, inconsistencies, typos, and so on. So these issues will confuse the model and ultimately will lead to bad insights and bad decisions, right? That's why data pre-processing is not optional, right? It is a very critical skill for every data scientist. So when we say bad data, what exactly do we mean? Okay, so there are 6 key dimensions or criterions we use to assess data quality, and knowing these will help catch issues early and improve the data set before modeling, right? So what are these criterions? So we can talk about the accuracy. This is the obvious one, right? So we want to know if the data factually is correct, right? For example, a customer's age listed as 28. Is it 28 or did someone accidentally type 280, right? The second data quality criterion is the completeness, right? Are we missing data somewhere, right? Maybe we're missing an entire column. It wasn't recorded, right? Or maybe the customer's phone number is blank, okay? So then we talk about consistency. If one system records, for example, CA, and the other one writes California, right? So they are actually referring to the same thing, but they don't match, right? So that inconsistency can break the model that you're using, right? The other thing is timeliness. So we want to know if the data is up to date, right? The next one is believability, and this is about trust, right? Does the data look authentic, or does it feel like someone gamed the system or entered some nonsense, right? And then lastly, interpretability. Can a human understand what the data means, right? So if we have like a column name X1 or Z2 with no metadata or with no documentation, even the best data miners or data scientists won't know what that means, right? So this diagram gives us a high-level overview of the different steps involved in data pre-processing, right? We start with data cleaning right here. It comes first, and think of it as removing dirt, right? So when we say dirt, in this context, things like the missing values, the typos, the duplicates, and so on. So anything that makes the data unreliable, right? And then we move up to data integration. As we said, the data actually comes from multiple sources or databases, right? And it has to be merged into one unified data set, right? So data has to be consolidated and integrated into one single clean source, right? Then comes the data reduction, and we know that real world data sets can actually be huge and overwhelming, so we may want to reduce the number of instances or features without, of course, losing much of the valuable information in your data. And then lastly, data transformation. That's where we adjust the values for better performance, as we will see. That's where we do things like normalization, encoding, and so on. So we will break these phases into two parts. So the first part will mainly focus on data cleaning. Got a lot of tasks to do here. And then the second part will focus on reduction and transformation. So as we said before, real-world data is incomplete, can be noisy, can be inconsistent, and these are some examples of problems in data, things like missing values right here, or simply missing because we did not record them, or simply missing because they're inapplicable. We can see things like duplicate right here, so the same record twice. We can see some very strange values that we call outliers, and so on. So sometimes the data is missing because the equipment didn't work correctly, or there was a problem during data recording. Sometimes the data is missing because it has to be inferred, right? Sometimes we have the value of feature A and feature B, and out of these we can infer feature C, which is A plus B, simply, right? And then sometimes the fact that the data is missing may have a significance or a meaning in itself. For example, a missing test in a medical examination, right? So how do we handle missing data? So the first step is simple. We can start by counting the number of missing values in each feature, right? So this helps you spot whether the issue is small and isolated or it's something more widespread in your data set, right? And then the next thing is we try to look at some patterns in the missing data, right? Are the values missing, or are the values missing at random, or is there any specific feature or a group where it happens more, right? And then thirdly, we could try to find some associations, right, between the missing and the observed data. For instance, our customers with missing age fields are more likely to be from a certain region or particular payment method, for example, right? So this could suggest that this is not a random missing, right? So it might be an important trend or an important piece of information in your data, right? So then finally, you ask the big question, is the data missing at random or intentionally or on purpose, as we just said. Now, after you've analyzed the whole situation and you answered the previous questions, come into how do I handle this problem. So there's two ways. There's the deletion or the discarding. This simply means to remove rows or columns, as we will see in a second. This is very fast and simple, but if the amount of missing data is big, you're obviously going to lose a lot of data. The second option right here is the imputation of data. This is spelled incorrectly. So imputation, or imputing actually, not imputation. So imputing the data simply means to fill in the blanks, right? So you can use things like the average, the median, as we will see in a second. So let's say we want to remove data, right? There's the option of removing the instance, right? So if we have an instance that have too many missing values, then it might make sense to completely get rid of that instance or that row, right? However, you should pay attention to the number of instances or rows where this problem happens and the overall size of your data set, right? So if 5 out of 100 rows have missing values, then it might be reasonable to delete. But if you only have 10 rows or 10 instances in your data overall, then it's not really a good, wise choice to remove 5 out of 10. Now, this diagram shows two common approaches for handling missing data by deletion. You could apply list-wise deletion or pairwise deletion, right? So in list-wise deletion, if even one value is missing in a row, the entire row is removed, right? You can see here that most of the data set gets wiped out just because one column in each row has a non-value, right? So here you might lose a lot of information unnecessarily, right? The second option is pairwise deletion. This is actually more flexible. So instead of throwing out the whole row, it uses all available data feature by feature, right? So for example, if you are analyzing just the beds and say the price, it will include any instance that has values for just those features, even if something else is missing, okay? The second option of discarding data is to remove features. So instead of removing instances, you could remove features. So if the proportion of missing values for a given feature in a data set is more than 60%, yes, you could go for deletion. Delete that feature completely because it's not going to add any value to your analysis, right? Now, there are other situations where you would want a feature removal, things like a duplicate feature, right? Or features with a high proportion of missing values, as we just said, or features with the same value for all instances, or the opposite, features with different value for each instance, things like the ID feature, for example. So these are some of the Python functions here that you can use from the pandas package to drop rows or features, to remove duplicates, to count the number of null values or NA. So we've talked about deletion. Now the second option is imputation, right? Imputing the data itself or filling the missing values instead of throwing them away, right? There's two ways you could do that. There's the univariate imputation. Here we fill the missing values based on a single feature, right? The most common methods are using the mean. So we calculate the average of the entire feature and we fill in the blank with that value. We could use things like the median, the mode, and so on. And then the other option of, again, data imputation is the multivariate imputation. This is more advanced. So here it uses relationships between features to guess the missing values, right? So here we use things like KNN or iterative imputation under this category. So the other data cleaning method or task is the data formatting. So all the data within one single column and across similar columns should follow a uniform format, right? Why is this important? Well, first, it makes it easier to do things like grouping, comparing, and also aggregating your data, right? And the second thing is consistent formatting reduces the chance of analysis errors, right? So you're not going to get things like double counting categories or failing to match values, right, in your data. So let's talk now about outlier analysis or outlier detection and handling. Again, this is still part of data cleaning. So outliers are data points that are unusually high or low, right, compared to the rest of the data. So these outliers could be genuine anomalies, right, or rare events, or just the result of data entry errors or mistakes, right? So, for instance, if most of the customers spend between 10 and 500 dollars, but there is one show that shows a purchase of 12K, right? So this is actually an outlier, but the reason or the type of the outlier could be a VIP customer, right? Or it could be just a typo, right? So why is it important to analyze outliers? Well, because they will distort your analysis, right? They pull the mean in their direction, right? They will stretch your scale, right? The min and the max. And can cause some models, especially those based on distances or assumptions, things like the normality assumptions, right? It can cause them to behave unpredictably, right? So then during pre-processing, you should always detect the presence of outliers, right? You should understand the type of the outlier and then decide how do you want to handle them. So as we said, outliers sometimes can be natural. So things like a student that scores well above the rest of a test, on a test, right? It got the highest score while the rest of the students got some some other grades that below that very high score, right? So this is an outlier, but it is actually a natural outlier versus other cases where it's actually an error. Things like a survey respondent who had entered a percentage instead of a decimal, right? So this is a data entry error type of an outlier, right? Sometimes it is a data pre-processing error during data transformation, for example, right? So all these are the different types of outliers, and there are some methods to automatically detect outliers in your data. This table summarizes a few. You could explore them later and try to apply some of these to your data sets in the lab. How do we handle data? So this slide right here has the different suggestions of how to clean an outlier depending on the type or depending on the type of the outlier itself. There is also this figure right here that gives you a few options of dealing and handling outliers in your data set. So I highly suggest you to review these and try to explore them and play with them with your data set in the lab.